In this video, we're going to be looking at convection currents, and to demonstrate that, we did a lab in class, and this is an attempt to explain at a molecular level what was going on during that lab. We had a beaker full of hot water that was set up directly beneath a clear plastic tote or bucket full of cool water from the faucet, and then food coloring was added to the bottom of the tote. And over time, what was observed was this fairly distinctive pattern where the food coloring would rise up, and then it would spread out at the surface in both directions. It would fall back down, and then it would come back to the center, and this pattern just kept repeating itself. And there's a particular reason for that, and what was going on is, for simplicity's sake, let's just say that the heat was transferred from this beaker to here. All right, and we're just going to leave it at that. So we have a heat source at the bottom of the plastic tote. And what that's causing is a transfer of thermal energy to the molecules, the water molecules that are down here at the bottom of the tote. Thermal energy, we recall, is really just the kinetic energy of the molecules. So these molecules down here are speeding up. And when they do that, their velocity is increasing, their collisions are increasing, and they're getting further apart from each other. When they get further apart, they become less dense. Less dense things are going to rise to the surface, and as they rise up, you have more dense molecules that are taking their place. So we have less dense molecules that are coming up, more dense molecules moving in, but then those more dense molecules are getting the thermal energy is getting transferred to them, their velocity is increasing, now they're becoming less dense, they're continuing to push the previous molecules up, and more molecules are coming in. And then once those molecules get here to the surface, we still have more dense molecules coming in. Well, they can't go up anymore, so they get pushed off to the sides. And what happens is, when they're at the surface up here, they start to cool down because they're bombarded with these air molecules here at the surface, and they're losing all their energy. As they cool down or their temperature decreases, they lose that kinetic energy and they become more dense again, and we see them come back down. Once they're back down, they're now the more dense molecules that are going to be pushing up the less dense by filling in that void where the less dense molecules were. Now, when you watch the videos of this, you'll probably have seen there was lots of cloudy haze mixed all in here, and eventually it spreads all the way through. And that's because even though this current is pretty distinctive, right, those molecules are still moving in random directions. So even though the majority of them might be moving like this, right, you have stragglers that are moving off in all these different directions. We're going to look at another example of a convection current, very similar to the first one, except this time we've got two beakers, and they've been dispersed they've been located at the ends of the tote full of clear water, and we still had the food dye, and that's evidenced in our video that you can watch, that was located at the bottom. And the reason for that food dye was just for contrast to help us see the current. We still have a very similar predictable pattern, but now instead of going up the surface, the food dye is going up, it's going over, it's dropping back down, and it's coming back here. And then on this side, we have the similar type of thing. Whoops. Redo that. Up, over, down, and back. And just like before, the reason for this was because we had molecules that were being heated, their temperature was increasing, their velocity was increasing, they were becoming less dense. They traveled up as more dense molecules took their place. Less dense continue to go up, denser molecules take their place, they're getting pushed over, they're cooling off, their temperature's decreasing, less velocity, more dense, they're dropping back down, and the cycle's repeating itself, except now, all right, we have the cycle repeating itself kind of in two places, but following the same type of pattern as before.